Welcome back to the top 10 ways to improve data warehouse performance. The last episode, we covered query optimization and before that, primary indexes. Now, in most cases, the combination of that sparse index and query optimization, which is automatic, is enough. But sometimes you need more. So for those cases, we've added other types of indexes, and one of the most popular is aggregating indexes. If you have a lot of metrics to compute for dashboards, sometimes the best thing to do is just pre-compute. If you saw the last episode on query optimization, you might remember that little box, other indexes, during the query optimization. There are lots of other indexes the query optimizer can use. In particular, you can have any number of aggregating or join indexes associated with any table. But let's see it in action to see how the query optimizer actually uses these indexes and what these indexes look like. So I'm back in Firebolt Manager. And what we're looking at right now is that query that was the detail table inside the Looker dashboard, which has a whole bunch of metrics. Now, if I'm running this right now, and by the way, I've done a little trick. I actually have only the primary index on and any aggregating indexes turned off. So if I run this, it's actually running pretty fast and only scanning a gig of data. But if you look at the predicates, it's because it has selected the media type. Let's say now I want to do this for all media types and make a pretty massive query. If I run this right now for 3 weeks of data, it's taking a while. It's taking 5 seconds and scanning over 80 gigabytes of data. Even if I do this for 1 week, it is scanning about the third, a little over a third, 30 plus gigabytes of data and taking a couple seconds, but it's pretty massive. So how do I improve the performance of something like this? Well, one answer is to use an aggregating index. So let me show you what it looks like first. I basically take these fields and turn it into an equivalent pre-computed aggregating index. I do that with one line of SQL. So what I can do is simply define those columns as in one line of SQL as an aggregating index on the LTV table. So with each write that's happening into the fact table, it is also updating the aggregating index. So I will go back to here, and I'm just going to do one trick. I'm going to turn on aggregating indexes. So we're no longer just running primary now. We're going to start using that aggregating index as well. And now I'm going to run this whole script. Now you can see we're running in under a second and only scanning 5 gigs of data. We basically dropped 80 gigs of data in the scan because the query optimizer has found the aggregating index and swapped in those pre-computed results with the 80 gigs of data that it needed and all the compute that it needed to do those aggregations and build that result set. So now I can even, without a lot of additional costs, have that aggregating index and start dialing down my compute cluster. So now I can go down to half the size and still get under 2 seconds of performance for that massive query. And that is how people using indexing not only improve performance, but start dialing down their total cost of ownership as well. All right. So aggregating indexes is one type of index you can use. The other popular one is the join index, which we'll cover next.